Hello, in this long video I'm going to solve the following challenging problem on the topic of indefinite integrals. Compute the following integral. Integral of f of x over this expression dx, where f of x, the expression in the numerator, is defined in this way, with this long expression. This video is made in response to a viewer's request posted in the following Telegram group. This is the link. Please join if you have problems to suggest or questions to ask. I would recommend you to pause the video at this point and give it a try yourself first. Okay, so now let us solve the problem. I have written that expression given the problem in the numerator here because I think it would be easier to see it. The first thing that it is understandable easily, more or less, is that cosine x, and cosine x appears in all these expressions. So it will allow me to think about, might be pulling it out is a good idea. I'm lazy to write it down all the way around, so if you don't mind, let me just clean cosine x from all these terms and then put it here in front of my fraction. The second thing that comes to mind is that if you look into the numerator, and here, by the way, there's a product that's left here, the product left there, yes. So if you look here, the left-hand side, just the fraction that you see is just a function of sine x, okay? So it motivates us to introduce a new variable, so let me call t to be sine x, and write my integral in terms of t, and it becomes much simpler, as you will see. Because if I take t equals to sine x, then of course dt becomes cosine x dx. Okay, so what happens, this means that this cosine x dx at the very end can be written as dt, and everything else can be written in terms of t, because everything is written in terms of sine. So my integral that I called it I becomes equal to square root of 1 plus t squared times 1 plus t plus 1 plus t, and then sine hyperbolic inverse of t multiplied by another t minus 0.5 1 plus t squared, and then I will have ln of t plus the square root of 1 plus t squared, and then everything all over divided by this expression, which can also be written as 1 plus t cubed 1 plus t squared, and as I told you there, dt. Another thing that you have to know is this famous ln function. ln of t plus the square root of 1 plus t squared, if you just refer to any standard calculus book, you will see that this can also be written as sine hyperbolic inverse of t. Okay? So now my goal is to do what? I want to decompose this fraction into two fractions. One, this one divided by that, and then the rest, what is left, divided by that expression. Okay, so I will decompose my integral to two integrals. One integral of this divided by that, okay, this one divided by this, but from this power of 3, I can pull 1 plus t out, and 1 plus t is left under the square root sign, and of course I will also have 1 plus t squared that can be written as 2 squares. Yes, let me write it like that, because the next step I want to simplify that. So this I will decompose it into two square signs. One of them I can write it like this, the other one I can write it like this, and then dt, and then plus another integral, what is left divided by that expression. But these two have this sine hyperbolic inverse of t in common, so if you don't mind, let me pull it out here, dt, and the denominator, I can write it for the time being like that, or I can write it like this, 1 plus t, and then I can write 1 plus t, and then I can write 1 plus t squared, okay? and then this is pulled out, t times that is left, okay, minus 0.5 times this is left, and then of course I pull sine inverse, hyperbolic inverse of t out. Yes? So that was not hard to see. This one is extremely simple because everything is cancelled out more or less. This one and that one are gone, this one and that one are gone, and then I am left with, let me write it down. Okay, so if you don't mind, let me open some space here and continue here. So this becomes equal to the integral of 1 over square root of t plus 1 dt. Okay, so if you don't mind, let me do it like this because then I have to repeat everything. So let me call this one integral I integral j1, and let me call the rest integral j2. So here I want to calculate j1. But in order to calculate j1, it's an extremely simple one because this becomes simply 2 square root of t plus 1, yes? Yeah, because some people have this in their memory, otherwise you take it to be u and bring it out and then solve it by another substitution method. But that's extremely simple. So that is it. That's done. But for calculating the second integral, my first wrong move was to simplify the numerator. Okay? It was not a good way because then I got stuck. I tried to do a lot of things, but I couldn't. Then I realized I wanted to I started redoing the problem. Then I realized that I wasn't in the right one because this 1 plus t, so some problem is designed in a way it is giving you a hint how to continue, okay? Especially when you see this 0.5 there. So this 1 plus t is the same expression as 1 plus t here. And 1 plus t squared is the same expression as here. Okay, I was careless when I actually started simplifying the numerator, okay? Because usually this hints towards the decomposition of the fraction one more step. And that is the tricky part, because this is, you have to be a little bit creative here. So if you don't mind, let me move this fraction for you only here. And then simplify this fraction. Not simplify, I want to write it in a way that manifests itself how to continue. My claim is that this can be written as the derivative of a function in terms of t. This is my claim, and I want to show it for you. So let me rewrite the fraction in front of your eyes again. 1 t times this minus 0.5 1 plus t squared divided by 1 plus t. I want to do this step by step. Okay, 1 plus t, and then if you don't mind here, I just decompose it into the product of two square roots. Yes? Of course, assuming that 1 plus t is positive. And of course, 1 plus t should be positive because it also appears here with the power of 3. If 1 plus t is negative, that is not defined in the first place, so they cannot ask this question. So they are assuming that 1 plus t is positive. Okay, now what I will do, I will decompose my fraction. I will write all the steps so that you are not confused. This one divided by the whole expression minus this one divided by the whole expression okay? But let us try to simplify to see if there's something good coming out of it. So this and that are gone. And I will write this t with this one in its denominator multiplied by 1 over square root of 1 plus t. Yes? 1 times t is t, and this 1 times that one is what is left. That's correct. And here what I will do like this. 1 plus t squared can be viewed as 1 square root of 1 plus t squared to the power of 2. So one of them and this one is cancelled. 1 square root of 1 plus t squared will be left for me in the numerator. Then what I will do, I would write this as 0.5 divided by this one can be written as, let me combine them back, so it becomes 1 plus t cubed the second. Okay, so this expression, which is this part of the J2 integral, can be written in this form, yes? Okay, but now what I'm saying is that if you don't mind, let me make this plus, you will see why, and put the minus sign here. It doesn't matter, yes? But now, if you were a little bit experienced, this combination is the derivative of a function. Which function? This function, 1 plus t squared prime. It's a very simple task. If you want to differentiate this, you have to differentiate this, which becomes 2t divided by 2 squared root of 1 plus t squared. The 2's are cancelled, so that's it. So this expression can be written as the derivative of that one. Let me repeat this expression for the time being. Now hopefully you understand what is happening. Now this function is repeating itself here. Okay? But my claim is that this one is the derivative of this function. I write it down, then I prove my claim. Okay? Okay, first of all, let me convince you of what I have done is right. Meaning that, let me differentiate this function and convince you that this is exactly this expression. I can do it here, okay? So what I want to do, I want to calculate the derivative of this expression. Okay, if you are experienced, these kinds of calculations are more or less instant. Okay, so this one, I can write it as 1 plus t to the power of minus 0.5. And then I want to differentiate it, so minus 0.5 goes down, and then it becomes 1 plus t to the power of minus 0.5 minus 1, which becomes minus 1.5. And then this becomes minus 0.5. I bring it down, so it becomes 1 plus t to the power of 1.5, but 1.5 is 3 over 2, so it becomes the square root of 1 plus t to the power of 3. Yes, that's exactly that expression. So I was able to prove my claim. But now hopefully you can guess what is happening. A function derivative multiplied by another function plus the other way around. The first function itself multiplied by the derivative of the second function. So what is this? This is the product rule of differentiation, isn't it? So I can write it as 1 plus t squared multiplied by 1 over 1 plus t totally derivative. This is a product. The derivative of the first one multiplied by the second one plus the first one itself multiplied by the derivative of the second one. And if you don't mind, let me just write it a little bit more beautiful. So 1 plus t goes to the numerator, 1 plus t is left. So that was my whole point. And that was, you see, the question was designed in that way to somehow guide you, do not open it up, which was my mistake in the first attempt. Okay, so now what I was showing to you, I would go and calculate J2 for you. Everyone probably can calculate that. So, integral, instead of this expression, I write the derivative of this. And if you don't mind, let me write sine hyperbolic inverse first. T. And then the fraction, which can be written as 1 plus t squared over 1 plus t dt, prime dt. Now, if you are experienced in integration by parts, this is crying out, you can solve me using integration by parts, because you can immediately call this part dv and call this part u. Okay, integral u dv by integration by parts formula can be written as uv minus the other way around, v du. So if I take this one u and I take this one to be dv, so this becomes integral u dv. But I need to calculate u, I need to know u and v and du. Okay? So u is this expression. If I want to calculate dt, this is du, sorry. This is also standard. The derivative of sine hyperbolic inverse of t is 1 over square root of t squared plus 1 dt. This is your derivative. And of course, if I take 1 plus t squared 1 plus t prime dt to be my dv, if I ask you what v is, of course v is this function itself. Why? Because the derivative of this function is the derivative of that function. So then it means that integral j2 can be written as, according to the formula, u times v. This is your u, this is your v, multiply them. So it becomes square root of 1 plus t squared over 1 plus t sine hyperbolic inverse of t minus integral of v du. Yes? So what is du? Du is this expression. V is this expression times du, which is this expression. Yes? But this one and that one are gone. So this becomes exactly the integral j1 again. So j2 becomes a square root of 1 plus t squared 1 plus t sine hyperbolic inverse of t, and then what you have here is dt over square root of 1 plus t that you see on the board now is just j1, yes, and j1 was calculated to be that. Yes? Yes. So that is j1. And by the way, so j1, so yeah, it was tricky. So because if you want, you can write j1. You don't need to write that. Yes. Why is that? Because I was able to show that j2 is this expression minus j1. Yes. Yes. There are no extra factors I am losing. No. So then, what can I do? I can move j1 to the other side, so it becomes j1 plus j2 is equal to the square root of 1 plus t squared divided by 1 plus t, and then I have sine hyperbolic inverse of t, and of course, j1 plus j2 is exactly the integral that I want to calculate. Do you agree? Because the integral that I wanted to calculate, I called it I, and I came up to here, yes? And this is j1 and this is j2. So j1 plus j2 is the integral that I want to calculate. Okay, so might be I am going a little bit round, but that is correct. So this is the answer to your integral, okay? So integral I is this expression, but do you remember what was t? T was introduced by me to be sine x. So this becomes 1 plus sine x squared divided by 1 plus sine x, and then sine hyperbolic inverse of sine x, and then you have a constant c, of course, at the very end, and this will be the answer of your integral. Okay, so I don't know, now that I have solved the problem for you, I realize that might be, I could do it a little bit more efficiently, but I am sure that what I have done is correct. Of course, please write your comments if you see any mistakes, okay? But I'm 100% sure, more or less, that what I have done is completely right. So the whole point, because it took me some time to understand, my mistake, myself, was to simplify this expression. Okay, if I simplify this expression with the hope that I can get a complete square pattern so that I can simplify the expression, ignoring the fact that it is already crying out for me that, okay, this is the time to decompose your fraction into the sum of two fractions. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.